Hi guys, our project is airline delays analysis and prediction. It is a system to predict if a flight might be delayed or not to make travel easier. This is important because flight delays can be really frustrating. By getting weather and location data, we analyze the relationship between attributes and delay information. Then we use machine learning tools to make predictions. Our user-friendly website on AWS with a Cassandra database lets users input weather details for delay forecasts, and you guys are welcome to use it. Our project is divided into 4 parts. For data processing and analyzing, this section details our methods of collecting and analyzing data. For data visualization, this part shows the relationship between attributes and delay information. Also, for data prediction, here we explain how we trained models to forecast the flight delays, and the last part is our demo. In the data processing part, we showed how we gathered flight delay data from the Bureau of Transportation Statistics and the weather data from the National Centers for Environmental Information. We mainly focused on key factors affecting delays, dealt with outliers, and merged flight and weather data by matching airport names and dates.
Next is the data analyze part. So first, we took the time to understand the facts, and then we identified 20 facts for analyzing. We sorted them into 5 dimensions: date, depart time, location, and weather conditions. By using PySpark, we effectively extracted and transformed this data and created 31 CSV files. We discovered some interesting things. For example, from 2020 to 2022, both the number and average time of flight delays increased annually. Summer months from June to August and Friday showed a little higher delays. And flights departing time is important also. Flights depart between midnight and 4 a.m. have higher delays compared to daytime flights. This pattern was consistent across all years we analyzed. And also for location, we found that states like Texas and California have the most delays. And lastly, the weather condition also have a significant impact. Extreme weather like low visibility, high wind speed, and heavy precipitation lead to longer delays. In fact, these findings are not just statistics. They are useful for both airline industry and passengers, helping to anticipate and manage delays more effectively. We also encounter problems with code efficiency due to the large volume of data. We overcame them by applying techniques we learned from this class, like cache, join, and broadcast in PySpark. This helps us manage data more effectively. And next part, we'll talk about visualization. So for the data visualization, to make our dataset analyze more accessible and understandable, we transform our charts and models into web pages and deploy them on EC2 for viewing and user interaction. And we will present our live demo at the end of the presentation. On the front end, we use React and JavaScript for the basic framework and incorporated Chart.js and D3 for constructing interactive charts. In our first data source page, we record our inspiration and 2 raw data sources we used. And then in the second page is the data analysis page. We present the line, bar, and geographical charts to show the relationship between these facts and flight delay time. For time facts such as year, hour, we use line graphs. For geographical facts like airport state location, we use state maps to better see the average delay time for different states. And for weather facts like temperature, extreme weather conditions, we use the bar charts to better demonstrate how different weather affect delays. In our third page of a website, we developed a multi-layer perceptual model for users to predict flight delays. After users submit the airport data in a form, it will quickly return the prediction result and accuracy to inform user about their potential flight delay time. And next part is data prediction. This is the additional objective of our project and to offer a practical function for predicting flight delays. So we define it as a binary classification problem. flight depart on time or experience a delay of less than 15 minutes are labeled as Class 0. Flights are delayed more than 15 minutes or it's cancelled are labeled as Class 1. Considering the convenience, we use easy accessible weather facts and weather flight information available on the boarding pass as the input features. In the output section, the model will provide predicted classification results and a corresponding confidence level. To achieve better training results, we performed some pre-processing and feature engineering on the data. For certain flights labeled as cancelled in the original dataset, we randomly sampled from non-cancelled flights of the same year to fill in the missing feature. To address the issue of varying ranges and magnitude among numerical features, we normalized these features with employing standard scalar, and we transformed some non-numerical features into one-hot coding to prevent any numerical misleading impact on the model. To address the imbalance between the two classes of data, we employed oversampling in the training set to balance both classes, ensuring the model optimization does not favor one class over other. For the machine learning part, we chose the balanced F1 score as the evaluation matrix to provide a more representative measure of the data model performance. And the various machine learning models are used and tested in our dataset. Rigid classifier KNN and the decision tree exhibit underperforming. And that is because of high dimensionality of the input data. And the random forest and MLP perform comparably, but MLP is chosen finally because of the smaller model size and the faster convergence. And finally, we'll have our lab demo. Okay, so now let's take a look at our web page demo. So this is our main page, and we also have another 3 pages, the data source, data analysis, and the flight delay predictions. And you can also click these 3 blue tabs to navigate to these 3 pages. So let's first take a look at our data source page. So in the data source page, we have include our introduction for why we are going to do this project. And below, we have included 2 links of our raw datasets and the table of attributes. The first one is the weather dataset we got from the National Center for Environmental Information. And next is the US flight status dataset. And then let's take a look at the second page of our website, which is the data analysis. In this website, we have categorized the features into 3 tabs: the time, geography, and the weather. For the time, we have year, month, week, and hour. So for these 4 features, we use line charts to plot the graph, and you can choose to see which years or not. And next tab is the geography. So you can see it is the US map, and we have recorded the average delay time for each state of US. And the last tab is the weather. So you can see temperature, wind speed, and the snow dips. So these weather conditions are categorized into the bar charts to clearly see the influence of this weather. And then the last page, which is also last functionality of our project, is the flight delay prediction. So it is the submission form. So for example, I will enter the date, like today's date, and then I will enter the departure time, like 20 o'clock, and the 3 letters airport code like AOAX, and the temperature, average temperature, max temperature, and the mean temperature, and choose the visibility of today's date, and also include the weather conditions. And then I can click Start Predict, and I will immediately see the prediction result, which is the expected delay is 0 to 50 minutes with a prediction confidence. So that's mostly of our website demo. Thank you.